In this video, we are going to talk about orthogonal decomposition of vectors. If I have two vectors, u and v, right, then what I can do is decompose that vector u as the sum of two vectors. So I can write u as the sum of two vectors, and which you can do with any two vectors. But the kicker here is that you can do this in such a way as to make one of the vectors parallel to the vector v and the other orthogonal to v, which is this upside down t symbol right here. All right, and so one vector we've already talked about, right, and that is the projection, right? The projection, when you project u onto v, that vector is a scalar multiple of v, right? So it's already parallel to v, okay? It points in the same direction or opposite directions, which means it's parallel, right, to that v. And then all you would need to do is to get the orthogonal part is to take u and subtract off the projection. All right, it's pretty clear that if you add these vectors up, then it comes out to be u, and that's clear, right? Because of the fact that the projection of u onto v, and then here you have the opposite of the projection of u onto v. Those are going to be the zero vector, right, where all the components are zero, and then if you add that to u, it's just going to come out to be u. So these two vectors add up to be u. This one is parallel to v, right, because we know that the orthogonal projection is a scalar multiple, a constant times the vector, right? And so then this one is going to be orthogonal to that. Because of the way the orthogonal projection is, it's going to go on that along that perpendicular that we were dropping when we talked about the orthogonal projection. All right, so here, as an example of finding this decomposition, it says two vectors u and v are given. Write u as a sum of two vectors, one which is parallel to v and the other which is perpendicular to v. Okay, so what we'll need to do is to first calculate, let me write these vectors down. For 1, -2, v is -2, -1, 3. All right, the very first thing that we're going to have to do is to calculate the projection of u onto v, okay? And so that we know that that's going to be u dot v over v dot v times the vector v itself, all right? And so let's go ahead and calculate those out. So u is 4, 1, -2. Actually, I should have written u dot v there. V is -2, -1, 3. Let me just double check those. Okay. So when you dot that, you're going to get 4 times -2, that's -8, plus 1 times -1 is -1. -2 times 3 is -6. That comes out to be -15. And then v dot v is -2, -1, 3 dotted with -2, -1, 3. So that's going to be 4 plus 1 plus 9, which is 14. Okay, so the orthogonal projection is going to be -15/14 times v, which is -2 negative 1, 3. Okay, so that is part of the decomposition. And then the next thing that we'll have to do, that's the parallel part, right, of the decomposition. The next thing that we'll have to calculate is u minus the projection of u onto v. So that is going to be 4, 1, negative 2 minus, and I forgot to multiply this out, so I'm going to go ahead and do that now. So that's going to be 30 fourteenths. That's going to be 15 fourteenths. And this is going to be negative 45 fourteenths. And I'll reduce that stuff later. And so now I'll need a common denominator, right, which is going to be 14. So 4 times 14 would be 40 plus 16, 56. This would be 14 fourteenths, just getting a common denominator. And that would be minus 28 fourteenths. Like so. Okay. And then go ahead and subtract that out. 56 minus 30 would be 26 fourteenths. Uh, 14 fourteenths minus 15 fourteenths would be minus 1 14th. Negative 28 minus a negative 45, so that would be 17. Does that seem right? Yeah. Okay. And so that would be the other vector itself. So for the decomposition, right, u would be the projection, which is this vector here. So I can write that as, let's see, 15 sevenths, 15 fourteenths, negative 45 fourteenths. And that's the orthogonal projection. Of u onto v. And then plus, this is the orthogonal part. That's going to be 13 sevenths if you reduce, negative 1 14th, and 17 14ths on this one. And that is going to be the part that's orthogonal to v. Okay, and so that's the decomposition. So I've written the vector u as the sum of two vectors, one of which is parallel to v, the other which is orthogonal to v.